Well, guys, thank you for coming. We're going to just do it fast. I'm Antonio Gomez. I'm a front-end developer, 3D generalist, thinker, and nerd. I'm from Mexico City, so sorry for the strong accent. You can reach me on hello@antoniogomez.me or with the handle Fragment. So I want to just talk a little bit more about interactive 3D content for the web made easy. So things around WebGL. So suppose you're wondering what is WebGL. WebGL stands for Web Graphic Library, and it's a JavaScript API for rendering interactive 2D and 3D computer graphics within the compatible web browsers without the use of plugins. So that's true. We don't need more Flash. So now's the time that Flash is dying. So we need to extend the web browser capabilities to support WebGL. So, and the good thing is that the major browser vendors like Apple, Google, Mozilla, Opera, they're part of members of the WebGL working group. So they're pushing to make this gradually becoming a standard. So even for desktop and devices, so you can run on mobile devices. From there, while a simple cube on raw WebGL would take around 100 lines of JavaScript and shader code that is running on C, we found, and definitely looking forward for the development of three.js, that is easy to use library created by Ricardo Cabello and Mr. Tube, and of course maintained by the GitHub community, that can achieve robust 3D simulations with a fraction of code. So it gives us the flexibility to create and manipulate geometry, lights, scenes, materials, and particles on real time. So based on that, I'm going to just give a quick example of what we can do with three.js. Here we have a basic markup. I'm just adding here a simple style sheet. Our vendor in this case will be three.js, and our scene.js file on the bottom. From the CSS part, it's just simple reset with a margin and padding, and a simple gradient on the background. From the JavaScript point of view, some objects, well, everything's inside an immediately evoked function expression with some objects declared there. So we have a scene, camera, loader, renderer, container, some lights, a light rig, and a couple of functions that will explain a little bit more what they're doing during runtime. So from there, as I mentioned, there's the objects that are declared in the top. Under init function, I'm creating a new container. This one will be the one responsible for rendering the content. We need a scene where all objects will interact with. We need a camera. This camera takes a couple of parameters. We have the focal length, we have the aspect ratio, we have the nearest and farthest plane where the camera can render, and then we're adding that element to the scene that we declare on the top. From there, we need a renderer. This is the actual graphics that are performed on. And from there, we're setting up the size of that renderer and appending it to the container. From there, we set up our light rig. We lower geometry. In this case, what I did was extruding the San Diego JS logo in 3D space on a 3D package that's called Magia. And then from there, imported from there, well, exporting it onto Collada and then to JSON. So we're able to just load it here. So we're adding geometry that is based on JSON. From there, we animate that scene, and then we have a basic listener for the window resize event. Our light rig is pretty simple. We have a couple of lights here. They'll declare. It's all the kind of lights that we can have there on three.js. We added them to the scene. We load our geometry, then in this case a JSON file as I mentioned, and then we set up on a callback function just some scaling to that element and add it to the scene. From there, the render function, that is the core of three.js, will execute and provide us 60 frames each second. So from there, we can be able to just translate that camera and the position for X, Y, and Z. We look at the origin of the scene, and then we're animating that. We're animating the camera. So from there, based on that, this is the example running. So it's very basic. This is running real time. We have the geometry that is loaded. We have the light rig running. We have the camera. The camera actually is orbiting around the geometry. And the geometry is static in the center of the scene. And, well, that's it. Any questions? guys? Well, it depends on the complexity of the geometry. Definitely for this. You want to unplug it? Oh, yeah.